Our today's topic is velocity of forced mechanical oscillator, that is velocity of forced mechanical oscillator. As we have already studied the displacement of forced oscillator, now it is turn to discuss velocity. So, we know that velocity is nothing, velocity is the rate of change of displacement. As we know, the equation for displacement is x is equal to minus iota f naught upon omega zm into e raised to power minus iota omega t minus phi, sorry. So, this is the equation for displacement. Now, we will find velocity. So, we know that velocity is the rate of change of x. So, we will do the derivative of this equation. So, d dt of its derivative minus iota f naught upon omega zm e power iota omega t minus phi, this one. Now, we will take derivative minus iota upon omega zm is constant, it will come out, and f naught is also here, all are constants. Now, derivative of this e power iota theta is e power iota theta, that is it will remain same, e power iota omega t minus phi into derivative of this term, that is iota into omega. Okay. So, iota into iota, iota square, that is minus 1, minus 1 into minus plus. So, ultimately iota square is minus 1, you know that, and it will become f naught omega over omega zm e power iota omega t minus phi, and omega is cancelled with omega, and finally we will get velocity is equal to f naught upon zm e power iota omega t minus phi. So, this is an expression for velocity. Now, we will plot the graph between the phase difference between velocity and force, and then again in the second part we will find or trace the graph between velocity amplitude and driving force, we can see. So, now it is time to study the variation of phase difference between velocity, this one, and force with omega. Omega means with driving force frequency. So, first of all we have to find the phase difference between V and F. Phase means we will compare the angles used in velocity and angle used in force. Then we will compare the difference in their phases. So, what is this? We know that F is equal to f naught e power iota omega t, and we will split this force into two parts, that is e power iota theta means cos omega t plus iota sin omega t, or it is f naught cos omega t plus iota f naught sin omega t. You know that this is the equation for force, and this one is a real part and the second one is imaginary part. We already studied. So we will consider only a real part. So real part of force is F naught cos of omega t. This is real part of force. Now we will compare this real part of force with the real part of velocity. Now we have to solve the real part of velocity. So when we split this velocity in two parts, so this will become velocity is equal to F naught upon Zm into cos of omega t minus phi, and plus similarly F naught upon Zm into iota sine of omega t minus phi. So this is equation for velocity. This is real part because there is no any iota, and in this term iota used, therefore it is imaginary term. So real term and imaginary term. So we will compare only real term, real part of velocity, this one. It will become F naught upon Zm into cos omega t minus phi. So this is real part of velocity and real part of force. Now we will compare the phase or angle of these two equations. So on comparing only angles, because it is constant, this one is a term of velocity, this is a term of force. We will not concerned with these terms, we are only concerned with the phases or angles. So in the first case, in case of velocity, the angle is cos of this, it is also cos of. Here it is cos omega t minus phi, here cos omega t. So when we compare the angles, you will find that the phase difference between these two, velocity and force, is phi, because we will minus or subtract this omega t minus omega t plus phi, and ultimately we will get phi. So the phase difference between these two, velocity and force, is phi. So phi is the phase difference between velocity and force. So we have compared only real parts. So we can compare only real parts or compare imaginary parts, we will get the same answer. So I have already told you that we will consider only real part, because real part, this type of article is are solved in the book. So you may also compare many parts, but this is phi, phase difference. Now our article becomes phi versus omega. This is the variation of phi. Phi means phase difference between velocity and force, and omega. Omega is driving force frequency. So phi, what is phi? We know that there is formula tan phi is equal to m omega minus s pi omega over r. This is tan phi. So we will find the value of phi at different values of omega. So in this, it is just like as the same article which we have already discussed in the previous lecture. That is first case when omega tend to 0, that is at very low frequencies, omega tend to 0. When omega tend to 0, then it will become 0, it will become s by omega become infinity. It will become infinity. So 0 minus infinity upon something means tan phi is minus infinity. It will become minus infinity. And tan minus 90, because you know that tan 90 is infinity and tan minus 90 is minus infinity. So this is first point, first coordinate, that is when omega tend to 0, phi tends to minus pi by 2. This is first coordinate on location of first particle or first point in the graph. In the second case, when omega is very high, that is infinity, very high frequency. When omega tends to infinity, then in case of tan phi, m into infinity means infinity, minus something s upon infinity become 0, because something upon infinity is 0. So this term will dominate, infinity minus 0 upon anything. So infinity upon anything means infinity. This will become infinity and implies phi become pi by 2, okay, because tan 90 is to infinity. So second point is, these are coordinates of second point, omega tends to infinity and phi become pi by 2 means plus pi by 2. It is minus pi by 2. In the second case it is plus pi by 2. And third case, the frequency in between 0 and infinity, that is at resonance. Third point is at resonance, that is omega tends to or is equal to omega naught. What is omega naught? Because omega naught is S by m under root. It is the frequency of undamped oscillator. So when we put this value here, in case of tan phi, in this equation tan phi become m into omega, omega become S by m under root, S by m. So it will become m omega under root minus m omega under root upon r, that is 0. This will cancel and 0 upon r, that is 0. So tan phi becomes 0 and phi is also 0. So this is third point. When omega become omega naught, then phi become 0. So these are three coordinates, points, 3 points, and these points can be shown in the graph like this. That is, we will draw a plot graph between phi, this one, and omega along this side, phi omega graph. This is called phi omega graph. So in this case there are three values of omega, that is this first point, omega is 0, second point, omega is equal to omega naught, and third point, omega is infinity, this one. The 3 points. And when omega tend to 0, phi become minus 90. It means we have to consider or extend this phi values in negative side also. So that it is 0, it is plus pi by 2, and at the same distance it is minus pi by 2. Because plus pi by 2, 0 and minus pi by 2, because from these values it is clear that there are positive, negative and 0 values of phi. We will consider the values of phi in the graph. Now, when omega tend to 0, phi minus 90. Omega is 0, phi is minus 90, means this point is first point. And second point, omega tends to infinity, this one, phi become 90, means from this side this point is second point, this one. This is, and third point, omega tends to omega naught, this one, phi is 0, phi is 0 means itself, this point itself is the point. So when we join these points, so it will become, it will not become a straight line, it is just like a curve. So I have already discussed with you that if we study the point between omega naught and infinity, this one, or 0 and omega naught, then the points are not lying in a straight line. They are lying just like a curve. So it is curved in nature. Curve means this curve is like this, and it is upper side, curvature upper side, curvature lower side. So this is the graph for variation between phi and omega. So we will discuss the variation of velocity amplitude with driving force frequency in the next lecture. Thank you very much.